Hey, distance learners, you had a hard section today, so there's more of you gone today than are here. So Ellie and Eric and I are going to go slowly through number 3. You should also watch Miss Bale's notes, but then I would come and do number 3 with me and number 9 with me before you sail on your own on this worksheet. So that's for Julia, Miles, Lily, Nikki, all you guys, all right? So make sure you watch Miss Bale's notes first because I'm not giving notes. I'm just going to go through 2 examples. So I blew up number 3, and one of the things with this assignment, oops, sorry, that's a bunch of algebra stuff, is everything's so small. So I'm going to do it on a bigger scale. All right, so you guys at home, you're still going to be finding the area. We're still going to use the formula that we had last time, which was 1/2 of the A, which is the apothem, times n, the number of sides, times s, the side length. You'll be given one measurement on your figure. So the first thing I would do is go get the n by counting up the sides. I'm just going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have a nonagon, which means I have 9 sides, 9 central angles, and 9 triangles that are made. All right, so this n, when I go do it, is the number of sides, which for mine is a 9. The next thing is I decide if you have anything else. I told you I always like to deal with this front and center triangle, that one right there. And because it's regular, all the sides are 14. So I actually have a side length of number 3 as well. It's 14. All right, so I'm going to rewrite this. It's going to be 1/2 times I don't know, because I don't know the apothem. So far, nothing's different from our last section. But what's different now is how you're going to get that missing piece. And you should have watched the notes like these guys in class did. And they're going to say to use trig. And when Eric came in, he said, I get it, I'm just not sure which one to use. So I'm going to talk about that really slowly. I like to pull this triangle out and make a nice big one. And there's not much room on your worksheets. If I want to do it on a separate sheet of paper. In order for you to use trigonometry, you need a right triangle, and you also need an angle in the right triangle. So if you remember, I said there's 9 triangles on here. So the first thing she would have told you to do in your notes is to take 360 and divide it by 9, the number of sides. So let's make a step by step. Number 1, you're going to do 360 divided by the number of sides. For this one, 360 divided by 9 is 40 degrees. Are we good with that, Ellie? All right, so we have a 40-degree angle, and that angle is this whole piece right here. So we need the apothem, and remember the apothem is what we get when we drop that height down in there. We don't have that, but the minute I drop the height, what did I just do to the angle? I cut it in half. So step 2 is you're going to take that angle that you got, that 40 degrees, and you're going to divide it by 2. For mine, it'll be 40 divided by 2, which is a 20-degree angle. So I drop this down, cutting that 40 degree into a 20, and I also made a right triangle. All right? Now also, my side length was 14. So you'll notice over here, this whole length, this guy right here, is this guy right here, is 14. So I know another side of the triangle is 7, because that apothem not only cuts the angle in half, it cuts that opposite side in half. So kind of know that. So now I'm ready to use some trig. And if you watch the note, she's going to say, remember your so, ha, toa. And I'm videoing this so you can kind of pause while you do it, but they had this much done. So what I need to do is figure out, well, what do I need in my formula? And the answer is I need to figure out that apothem. So I need to go over here and figure out, well, what's this side? So I'm going to put a little a on there. So now we have to go back to that other chapter where you used your trig. You go to the angle, and you ask yourself what those 2 side lengths are. And you'll say, well, the 7 is across from it. It's an opposite side. And this A over here isn't the hypotenuse. The hypotenuse is always like these radii that are shooting. These are all hypotenuses. So it's not an hypotenuse, it's the adjacent, all right? And the apothem will always be the adjacent, which helps because they both start with the letter A. Does that make sense? So which one of these right here deals with the opposite and the adjacent? What do you think, Ellie? Tangent. So for mine, I'm going to pick tangent. I'm just going to put a little star here for mine, but it's not always tangent. It depends on what information they give you. But for this problem, number 3, it's tangent. So number 4, I'm going to set up the trig ratio. So we're going to do set up ratio. And we'll eventually put this on a note card, but there's so many of you gone, I'm not going to start a note card. So we're going to use tangent for ours. So we'll say the tangent of 20 degrees is equal to opposite over adjacent. The opposite is the 7. The adjacent is the A. Opposite over adjacent. And then you have to solve that for A. So remember, really what you're doing is multiplying both sides by what's on the bottom. And in this case, it's the A. So we have to go like this. We have to go like this. And these will cancel. Okay? So really what you end up with is A times the tangent of 20 degrees is equal to 7. So how do you solve that on your calculator? For the A, just take out your calculator. What did she say to round to? Or does it say in your worksheet?
It says round to the nearest.
To the nearest 10? Okay. Did she round as she went, or did she use 7 over tan 20 in the formula?
Yeah.
She used 7 over tan 20. Okay. So they're telling me that in class, they didn't go to their calculator yet to get this. They only went to their calculator one time, and it was at the end. So what you're going to do on your calculator, okay, for this one, is you're going to say it's a half. If you like to use 0.5, go ahead. And then you're going to do times. I'll put an X for times here just because I know, Nikki, you don't like the dots. All right, so I'm going to do 0.5 times 7. And then we have to divide by tan 20. Your calculator will make you close that off, so make sure you close it. And then times 9. And then times 14. So you're going to use trig to find 1 or 2 missing parts. In this problem, it was just 1 missing part. And I have no idea what this is, guys, because I don't have a calculator. Did you run it through?
Well, I'm confused. Why did you? Oh wait, never mind. I'm done.
No, you're
Because I got the one.
Did you do this one in class?
No, I didn't. Well, like, did I?
I'm going to enter this. I'm just going to make sure. 0.5 times 7 divided by tan. Oh, I have to make sure you're in degree mode, by the way, guys. If you're using my calculator, they're set for calculus and they're in radian mode. Are you using my calculator? Hit the mode button and go over to degree for geometry. I don't teach geometry. I teach a class that doesn't work with degrees. So times 7 divided by tan 20, close it, times 9 times 14, enter. I've got 1,211. Is that what you had to learn? Good. 1,211.64. So 1,211.64. All right. So again, if that went too fast, I think you probably didn't watch Miss Bale's notes again, which you should. We're going to hop on and do number 9 together, which neither of you two did 9, did you? Okay.
Yeah,
You didn't do it?
Go back.
Oh, yep, sure.
I still don't really get how you think it was 10. I mean, I just kind of looked at the notes.
Here, I'll show you. Well, while I'm waiting for her, the question was, how do I decide? I'm going to go here. Whether I do tangent or sine. So I'm going to draw one of those triangles. Again, we only focus on one of them. In this case, there are 9. I pulled one of them out. So Eric, if you look up here, if they gave you this side, let's say, and you figured out this angle was, let's say 35 degrees, right? You would have to look at this angle, and which one do you want to pretend you're finding, the bottom piece or the apothem?
Say bottom.
Bottom. So suppose he's looking for this piece down here. He's going to say that's an opposite. You look at this angle at the peak and you head across, that's opposite. The longest side over here on the slant is always the hypotenuse. The apothem is always the adjacent. So we're dealing with an opposite and a hypotenuse if that was the situation. So you would choose sine.
Okay, so if it's off, then so and for tan.
For tan, it would have been if this wasn't here, and maybe this was 5. And you'd say, well, now I've got opposite and adjacent.
And it's like that every single time.
Yeah, it's one of those 3 every single time.
And what's for co?
So let's go try this one and see how it works out. This is a 20 gon. So 20 gon means n is 20. I think if I were you at home or here, I'd write down the formula. And as we find stuff, I think we should plug it in. Okay, so I've got the n. I'm going to go put a 20 right there. It says the radius is 3. So I don't have the apothem or the side length. So I'm going to highlight those. Those are what I need to find. I don't want to draw a figure with 20 sides. So I'm just going to pull off one of the 20 triangles that would make it. So that's what I think you should draw for your sketch. I don't want to draw a 20-sided figure. All right. Then you have to decide where this number goes. The radius is always this part of it or this part of it. And I like to read left to right, so I'm going to put the 3 over here on the left. And now we're going to go through our steps. First thing we do is we have to figure out this angle up here. So we're going to do 360 divided by 20, because there's 20. If I had made this figure, I'd have 20 of those triangles going around there. 360 divided by 20, what is it? 18. Okay, so 18 degrees is that full central angle. The next thing I do is I drop the apothem. The minute I do, I've got a right triangle, which is nice, but my angle's no longer 18 because that apothem cut it in half. So that angle right there is 9 degrees. We good so far, Ellie? So now I have to figure out, well, what do I need to find? I need to find the apothem, so I'm going to label that with an A. And I need to find a side length. Well, I can't get the whole side. But I can get this piece of it and then double it. So I'm going to get the purple at the end when I double this. So I think I'm just going to call that X down there. What did she call it in class? Remember, did she use an X? I don't know. They don't know. I'm going to use an X. So now we're at the point where to find our A and our X, we need to use trig. So we've got to decide if we're going to use sine, or we're going to use cosine on our calculator, or we're going to use tangent on our calculator. So we're going to, what one do you guys want to find first, the A or the X? The X? All right, let's go do that. I'm going to go to a different color just so you can see me. You look at this angle and you say X is opposite. The other one I know with a number on it is the hypotenuse. So now you go back to here and you say which one of these deals with the O and the H. Sine. Yeah, so we're going to say sine of our 9 degrees is equal to opposite, calling X. I don't want to call it O because it looks like a 0. Over hypotenuse. You always multiply by what's on the bottom. So I'm going to multiply both sides by 3. It'll wipe it off on the right. And I'll have 3 sine 9 equals X. How are we doing, Els? But that's only this part of it. I need the whole side. So instead of 3 sine 9, guess what I'm going to use? I need to double it. So I'm going to use 6 sine 9. So I'm going to go like this because I've got to double it to get the whole side length down there. So we'd have 6 sine 9 is equal to the side length. I'm going to circle it. Yep.
You're doubling it because of that's the whole thing.
Yeah, the side length is this bottom part. Like if I had drawn all 20 rectangles or triangles, sorry, that make up this figure. These are the sides.
Okay.
But we can only get half of it with our trig, because trig only works for right triangles.
But why do you have to do sine 9 equals x squared, and why can't you just go straight to 3?
No, you have to set up the opposite over hypotenuse.
Oh,
Yep, so x over 3. So I'm not going to put that in yet. I'm going to now go find the apothem, and it's going to be almost the same thing, but the only difference is now I've got A. The apothem is the adjacent, so that A is nice, and the 3 is on the H. So for me to go figure out that apothem, I'm going to scroll a little bit. Okay, so that got me the side. Now to get the apothem, I'm going to say, well, I've got A and H, so I'm going to say cosine of the 9 degrees is equal to A over H, and H is 3. So when I saw that, I have to multiply both sides by 3, and my apothem becomes 3 cosine 9. I don't need to double that, because that is the apothem. All right, so I had to double this because it was only half of the side,
yeah,
but this guy is
that's
the
just-
apothem. Yep, so now on my calculator, it has to do all the work for me. So on my calculator, we're going to go up here, and we're going to do 0.5, and I'll write down what you do on your calculator, just in case those of you at home are wondering. You do a half or 0.5 times the apothem, which we just said is 3 cosine 9, times the number of sides, which was 20, times the side length, which was 6 sine 9. And make your calculator do it all, and I don't have one, so I'm going to have these two do it and see if they agree. And you can use parentheses too, if you kind of like parentheses better than these x's. So this is my A, this is my N, this is my S. Make sure your calculator's in degree mode, which if you have your own, it is, because when you buy them, actually it's not. When you buy them, they are defaulted to radian mode. So just make sure you're in degree mode. We'll run that through a calculator, and these two are going to tell me what we get. And I think we have time to try one more.
So you use cosine to find the apothem.
I did.
Okay.
And we'll pick another one like this. I want to make sure that, because you know how to work your calculator and you know how to start it. It's just right here where we need to make sure you know what you're doing. I'm going to see if he gets the same thing. Here, can I run it through that one real quick? I'm going to run it through. So we're just making sure we have a right answer on here. 0.5 times 3 cosine 9 times 20 times 6 cosine 9, enter. What did you say you got? Did not get that. Let me try it one more time. 3 cosine 9. Oh, I didn't close my cosine 9. Silly. Yep, I got that too. 27.81. All right, so this is 27.81. So make sure, I think one of you last week wasn't doing that either. Your calculator puts a parenthesis on those and you have to close it. We're going to do one more. Ellie, just pick one, okay? Get some blank paper here while she's picking one. We're not doing, you have to watch your notes for numbers 12 through 17, but they're super easy right now. That's not going to be your issue. Let's pick 1 and 4 through 11. Which one do you want? 10. All right, she's picking 10, so I'm going to write it down. We'll get as far as we can. We should be able to finish it, though. We'll pick up the speed a little bit. So it's a 15-sided figure, which has 15 sides and 15 interior angles, and it's made up of 15 triangles. Its perimeter, which means its distance around, is equal to 120 feet. All right, so it has 15 sides, and they give me the perimeter, and I need 1/2 times the apothem, which they did give me, times the number of sides, which they did give me, times. So remember, it's 1/2 ANS. I can get the side length. If you know the perimeter and you know how many sides there are, So if you know all the sides add up to 120 and there's 15 of them, how can I get the side length? Divide, yeah. So we divide 120 by 15, and that'll give us our S for the formula. 8. Perfect. So the only thing missing on this one is our apothem. I don't want to draw a 15-sided figure, so I'm just going to draw one of the 15 triangles made. I'm going to find this angle right here first. Do you remember how to do that, Ellie? 360 divided by what? 15. We're going to go find what's called that central angle. We're not going to put it on there, though. What'd you get when you did 360 divided by 15? 24. The minute we drop the apothem, that 24 becomes a what? Half of it, yeah. So we're going to take that 24, because that's this whole way, and the apothem cuts it in half. So I'm going to erase this. I want to keep this one nice and clean. So this guy right here is 12 degrees. That's what we'll be using in our trig ratio. Sine 12 or cosine 12 or tangent 12 equals. Now what we're stuck on sometimes is figuring out which trig ratio to use. We're looking for the apothem. So we're looking for the adjacent, and I don't know the hypotenuse, but I know this whole side length right here. You guys said that 120 divided by 15 is 8. So that whole side length is 8. So my question for you guys is, if that whole side length is 8, what's this piece of it? 4. Perfect. Because we have to focus on that right triangle. Now I want you two in here to decide if to get that apothem you're going to use sine, cosine, or tangent. Yes. And you didn't hear him. Eric said tangent. Because you take the one you're given, which is opposite, and the one you're looking for, which is adjacent. And that's your TOA. All right, so let's set it up. Tangent of my angle, the 9 degrees, is equal to the opposite, which is 4, over the adjacent. Do you remember what I do, Ellie, to figure this one out? Multiply by the bottom, yeah, which is an A. So I'm just quickly going to go times A. It'll wipe it off over here, and times A over here. So on my calculator, to figure out what the A is, I just need to do 4. But we're going to leave that off, so you just need to write it. A equals 4 over tangent of 9. All right, now where do I go? Back to the formula. So we're going to take out our... Pretty good? And I wouldn't do that on your calculator. Just one time, we're going to squiggle this up. We're going to go to our calculators. We're going to do 0.5 or a half, whichever you like better, times 4 divided by tangent of 9. Don't forget to close those parentheses, or if you're using the asterisk on your calculator instead.
Where did you get 9?
The 9 degree. Oh, 12. Why did I say 9? Duh. You're right. 12. It was the last problem. It wasn't 9. Sorry. 12. 12. That means you understand what you're doing there, kiddo. It does. Perfect. I don't have a calculator, so they're going to tell me what they get. Times 15 times 8.
I got 18.
I'm going to wait for you to enter it, Ellie, too. Let's see if you guys agree. You went 0.5 times 4 divided by tangent 12. You closed the 12.
Oh, 0.5?
Yeah, you have to do a half. Or a half.
I got
Oh, I just did 4.
Oh, yeah, you only did this part of it. We need more. It has to be multiplied by half and then part. You found the apothem, which is fine. What did you say you got for the whole thing, Ellie?
I got 40.8.
I don't even trust you. You've had the last 2 right. Let me see how you entered it, though, just before I cut the video off. Oh, you did 0.4, it's 0.5. Nope, you didn't enter it right. I'm going to go do it. So 0.5 or half times 4 divided by the tangent of 12 degrees, close it, times 15 times 8 equals. I got 1,149. You had a 0.4 right here, and you didn't divide. So we're gonna fix that. All right. 1,129 point some stuff. I'm not by the calculator anymore. All right, so a couple things, guys, when you're doing these. I wouldn't do them in that small space provided on the worksheet. I'd put all your work on another sheet and then just put your answers on there and then staple it on or something. Also, be very careful that when you're entering these things, like say you're doing sine of 24 degrees, make sure you close it before you keep on going with a parenthesis. What else was I going to have you beware of? I think that's it. All right, so we did 3 together. See you later.